manufacturing industry has been shaped by two great thinkers, Henry Ford and Taiichi Ohno. Henry Ford revolutionized the industry by introducing the concept of flow, and Taiichi Ohno took Henry Ford's concept and adapted it to Toyota production system that made the whole world change its view of inventory from asset to liability. The key starting point for Ford was to have an effective production. We must concentrate on improving the overall flow of the product through the production system. And he focused so heavily on it that by 1926, to manufacture a car from mining of the iron ore to a fully finished assembled car which composed of 5,000 parts was put onto the train for dispatch, took only 82 hours. That means from iron ore being brought to the factory to making of iron ore and all the processes put together and the car being put onto the trailer or the train for dispatch took only 82 hours. 80 years or maybe 100 years after Ford did this, we still can't meet the lead time. This was what Ford had achieved. Not only this, if he had achieved such a high rate of flow, he also achieved many other things. The labor productivity had gone up, the quality defects had gone down, and finally he was able to also reduce the price of the car so that everybody could afford. What does flow mean? Flow means all the inventories in the operation are constantly moving. If this movement is stopped, the inventory accumulates. Where does this inventory accumulate? In the space provided. Ford was so heavily focused on making sure that the inventory never accumulated that he hardly left any space between two stations. And once this space was removed between two stations, slowly one station merged into second station, and then later on the assembly line concept was born. So what he did was, he made sure that the inventory did not sit anywhere. Naturally, if there was a breakdown or there was a problem with an assembly, a lot of workers would stop working because they just wouldn't have any material to work on. But that was not the prime target of Henry Ford. He focused so heavily, the flow of material should not stop, that he made sure that there was heavy standardization and any non-productive work was done offline. Getting prepared to assemble a part, please get prepared offline, but when you are online, you're constantly assembling. So what was great about it? He used space as his control factor. He reduced the space, the material could not sit anywhere. If material could not sit anywhere, how will it accumulate? Now, what are the repercussions of this? The repercussions of such a system are many. Let's take the first one. If the space is limited, the worker will stop producing when the space gets full. When the worker stops and you're measuring efficiencies, your efficiencies have gone down. And this would not be a good thing to do, because it is deemed in our mind that the more a worker works on a workstation or on a machine, the least cost and more efficient my operations are. However, there's another big thing that comes out. For example, a machine has broken down and the worker or the station is not able to produce. What would happen? Everything downstream would dry up. This would allow you to focus also on a point so that such stoppages don't take place. What does one mean by this? If you are looking at a place which is causing frequent stoppages, in another word, you are trying to see what is stopping the flow. That means that you are looking at ways and methods to look at how to balance the flow. And where to look at it appears very quickly in front of you, because that is the place which is stopping the flow of material. Or beyond that place, there's less material in the pipeline. It not only helped Ford focus or look at places which are disrupting flow, also look at places where the capacity constraint was there or the work distribution was not done properly, which increased the time required for a worker to work on the material. That means it was very easy for him, by reducing space, to find out where to balance the flow. So let's recap. The flow lines were set up by Henry Ford, so the material moved quickly. In these flow lines, there was very less space between one station and second station. So very less inventory or no inventory was allowed to accumulate. As these flow lines improved, the material movement system was taken over by conveyor belt, and over a period of time, the modern assembly line was born. Let's take a step back and think what was happening. The reason we allow inventory to pile up between two stations is to make them independent of each other. If there is no inventory between two stations, and if this is upstream and this is downstream, and there is very less inventory, if the upstream manufacturing station goes down, the downstream manufacturing station will consume this inventory in between and then go down. So there is a time difference between the upstream and the downstream manufacturing station. Higher the inventory, more are the operations of downstream insulated from disruptions of upstream operations. And if our operations keep working, we consider this operation to be efficient, and if it doesn't work, it is losing its efficiency. The reason why we make them independent is, it is a belief, it's a conventional belief that this increases efficiency of the system, of the operations. What Ford did, he didn't allow this inventory to pile up, and the mechanism was to reduce space. You don't give enough space for the inventory to pile up, and as he kept reducing the space, the inventory between two stations kept going down. Now, if this inventory kept going down, that means he forced the downstream operation to be dependent on the upstream operation. Now, just imagine if, while trying to achieve this, you keep your conventional wisdom on to say that I have to measure the local efficiencies. I just explained that the efficiencies are decided by the output that an individual workstation gives. That means the local efficiencies. And to get these efficiencies up, we allowed inventory to pile up between two workstations. So now you have reduced the inventory. If you have reduced the inventory and still continue to measure local efficiencies, where do you go? It's a huge conflict.